Alright, we didn't cover these in class. I'll go over them right now. 54, it's more probability. Again, we had 15 marbles. Probability that a marble is red or blue. The probability that a marble is red is 3 out of 15 because there's 3 red marbles. And the probability that a marble is blue is 3 out of 15 and 6 out of 15. Now when you're doing an OR, you're going to take the two probabilities and you're going to add them together. So the probability that something could be red or blue would be 3 out of 15 plus 6 out of 15, which is 9 out of 15, and that can be reduced to 3 out of 5. Okay. In 56, the question is, what's the probability that a marble is not black? So, in other words, what's the probability that it's red, green, or blue? So you can take the probability. All the probabilities add up to 1. The probability that it's black, the probability that it's red, green, blue. All of those fractions, when they're added up together, add up to 1. So if you take 1 and subtract the probability of black from it, which is called the complement, take the complement of the probability of black. There's 2 black marbles. You'll take 1 minus 2 over 15, and that'll be 13 out of 15. So the probability of a marble not being black is 1 minus the probability that it's black, or 13 out of 15. Or you could simply add together 3 out of 15, the probability of red, plus 4 out of 15, probability of green, plus 6 out of 15, probability that it's blue. 3 plus 4 plus 6 is 13. The denominator is 15. So you could also do it that way, and that's perfectly fine. All right, 58. Movie theater, snack specials. You can choose a small, medium, large, or jumbo popcorn. So you got 4 choices for the popcorn. Now you're only going to take one of them. That's what makes this easy. You're only taking one out of each one of these things. You're not going to get a small and a jumbo, or a small or a large, or whatever. You're going to take one of the 4. So you can take one of the sizes. You can get butter or not butter. Okay, it's not like you can get butter, a lot of butter, sort of a lot, or something. You only got 2 choices: butter, yes or no. So that's just 2. And for the drink, you can get a Coke or you can get water. And that's it, or soda, I guess. So you got 2 choices for the drink, 2 for the butter, and 4 for the size. You're taking one of each, so you're using the multiplication counting principle, which is now you're going to just simply take each choice and multiply them times the other choice. 14 times 2 times 2, 16. So there's 16 different ways you can get popcorn with or without butter and a drink with this setup. 60. All right, so now we're doing odds. Now probability. Notice that the denominator for each one of these probabilities is 15. In other words, the number of successes, like the probability of red, it's the number of reds over the total number of marbles, or we could think of this as successes over the sample space. So that's probability. Now odds is the ratio of successes to failures. Or you could think of it as sample space minus successes. But let's add that notion here for odds. That it's the ratio of successes to failures, which is the sample space minus the successes. So successes and failures should add up to being the same as the sample space. Okay? All right, so value less than 25 cents. Well, the sample space is 50. We got 50 coins. So we got 20 pennies, 50 nickels, and 3 dimes for a total of 38 coins that are less than 25 cents. Now, if we were doing the probability of being less than 25 cents, that would be 38 over 50 or 19 over 25 or whatever. Okay, but we want to know the odds. So we're going to do 38 in a ratio of 50 minus 38. So that's 38 to 12. So the odds are 19 to 6 of a value less than 25 cents. Okay. So that's 60, 62, a value less than a nickel. Okay, well, there's 20 pennies. If we're doing the probability of getting a penny, it would be 20 out of 50, 2 out of 5. But we want the odds of getting a 50, so that's going to be success versus failures. So you can do 20 over 50, or we use the colon notation, 2 to 3. Okay, 50 minus 20 is 30. We reduce that. You could say 20 to 30, okay, or 2 to 3. Okay, now 64. Marcos has 7 cards. Now, how many different ways can he deal these cards out? Can he hand these cards out? Here, let's take a look at this. That's 64. That's on the other side of the thing here. Let me stretch this out a little bit. Okay, so there's 64. Okay, says how many different ways can he play his cards? So we're interested in how many, in permutations. So he's got 7 cards to start with. So there's 7 different ways he can play the first card, right? Okay, now he's played his first card. Let's just say, for the sake of argument, he's got the 2 through 8 of clubs. Okay, 2 through, that's 7 cards. Okay, so let's say he plays, for the sake of argument, he plays the 2 of clubs for his first card. Okay, but he had 7 different cards he could choose from for that first card. Now he's only got 6 cards left. Okay, so there's only 6 different things he can choose from for his second card. And then he plays one. Let's say he plays the 3 of clubs. Okay, so now he's got 5 cards left. So he's only got 5 different ways he can play the third card. Say he plays, 2, 3, 4 of clubs. Okay, 4th card, only 5. There's only 4 cards left. He's played 3. He's got to hit 7 to begin with. Okay, so there's only 4 different ways he can play those cards. So let's see, we said 2, 3, 4. So he plays a 5. Okay. He's very methodical. All right. He now has 3 cards left, the 6, 7, and 8 of clubs. There's only 3 different ways he can play those 3 cards. So you can see the number of ways he can deal the subsequent cards is diminished by having played the previous card. Okay, so he plays the, 2, 3, 4, 5, 6. He plays the 6. He's got 2 cards left, the 7 and 8. So he's got 2 different ways he can play those. He plays the 7, and he's only got 1 different way he can play the last card, which is the 8. Now this is called 7 factorial. But the main thing is to understand the logic of Marcos's choices. That's the important idea here. So I can see that 7 times 6 is 42 times 10. So I did the 7 times 6, which I know. Actually, I could have done 7 times, let's see, no. 7 times 6 is 42 times 10. So times 2 times 5 is 10. So that's 420. And that leaves the 3 times 4, which is 12, which I do now with multiplication. And so there are 5,040 different ways that he could have played those 7 cards. Okay. 66. Find mean, median, mode. Okay. Well, the mean. Take the 8 numbers, add them up, divide by 8. Okay, that's the mean, 32.375. It does not matter what order the cards are in, obviously. Okay, now the median, you got to put them in ascending order. And then find if the number of cards is odd, you get the card in the middle. That's the median. If the number of cards is even, you get the two numbers in the middle, add them together and divide by 2, and is your median. So this is 8 numbers. So the two numbers in the middle is 30 and 33, and so the median is 31.5. The mode is a sub-median, if you will. Now, this distribution in ascending order splits up into 2 halves. 22, 24, 30, and 30 is the first half. 33, 38, 41, and 41 is the second half. So the first quartile is the median for the first half. So that's the two middle numbers of the first 4 numbers. First half is 24 and 30. So we take 24 and 30. I'm sorry, we're not doing that here. All we're doing is we're just doing the median. All right, we're done with the median. We're not doing Q1 and Q3. That's another problem. Okay, the mode. 30 is if each number only occurred once, then we would not consider ourselves to have a mode. But we got 2 doubles. We got 30 and 30 and 41 and 41, so they're both considered to be modes. All right, 68. Kevin wants the average of 90. He's got 4 tests under his belt. 88, 92, 82, and 94 is his previous scores. What must his next score, his 5th score, be to get a 90 average? Well, we can write it down like we're computing an average. 88 plus 92 plus 82 plus 94 plus x divided by 5 equals 90, right? The formula for the average. And then simply solve for x. Multiply both sides by 5. And you get 88 plus 92 plus 82 plus 94 plus x equals 450. Subtract 88 plus 92 plus 82 plus 94 from both sides, and you get x equals 94. Okay, double box plot. Now this is a pain. I'm definitely not going to give you one of these. I may give you one box plot, but I'm definitely not going to give you a double. It's just so much work. It's very time consuming, and a lot of other things that are more interesting to know. As I've said in class, this would always be done on a calculator. But anyway, you got 12 numbers in each distribution, distribution A and distribution B. So you got to calculate Q1, the median, and Q3, and the min and the max. So you put them in ascending order for each distribution. You can see the numbers are here. I put them in ascending order. This is where most of your mistakes are going to be made. Obviously, you could skip one or get them out of order or whatever. Anyway, the median, since it's the number of items in each distribution is even, so the median is going to be the two middle numbers divided by 2. In A, the two middle numbers 6 and 7, data elements 6 and 7, the two middle numbers are 26 and 26. So the median is 26. Now, if we look at the left-hand 6 numbers, the two middle numbers of the left-hand 6 are 20 and 22. We average those two and we get 21. And of the right-hand 6 numbers, we take the middle, that would be numbers 3 and 4 of the right-hand 6, which are 29 and 31. We average those to be 30. So for distribution A, Q1 is 19. The median is 26, and Q3 is 30. Now, for B, we go through the same process. The two middle numbers for the median of the whole distribution are 19 and 20, so the median is 19.5. Okay, for the first quartile, the two middle numbers are 16 and 17, so Q1 is 16.5. And for Q3, the two middle numbers are 21 and 22. For the first quartile, the third quartile is 21.5. Okay, now for distribution A, first thing I'm going to put down, well, there's different ways to do this, but let's put down the min, which is 18. That's the left-hand whisker. And we can put down the max, which is the right-hand whisker, 35. Then we can put down Q1, which is 19. I'm sorry. Q1 is 21. I'm sorry. Q1 is 21. I said it was. I was looking at the wrong numbers. Anyway, I have it here on the screen. All right, it's the average of 20 and 22. So anyway, here's Q1. Here's the median, which is 26, and then here's Q3, which is 30. Now, Q1 and Q3 are enclosed in a box, and the box is the IQR. That's the middle 50%. So from the min to Q1, this is 25% of the numbers in the distribution. From Q1 to the median is the next 25%. From the median to Q3 is the next 25%. And from Q3 to the max is the 75% to 100%. So in between Q1 and Q3 is the middle 50%, the IQR, the interquartile range. Okay, let's do B. And so we said the min is 16 and the max is 30. We can see that here from our distribution. Q1 is right close to the min, 16.5, so that's right here. 19.5 is the median, and 21.5, which is approximately, it should be a little bit over this way. I got it. This should be over here. It should be more like that instead of here. Anyway, I can erase that. Here, let's get that back. Okay, there we go. All right, and then let's get them on. Okay. And then, all right, so you see the three quartiles. Now, this distribution is not as even as A. And this is one of the things you would talk about if you were comparing the distributions. A is a lot more symmetrical. Okay. A lot of the numbers are in quartile, in the first quartile from 16 to 16.5. There's 25% of the numbers right there. There's just a few numbers, then there's a huge spread. The numbers are spread out from quartile 3 to the max. And possibly 30 is an outlier, but probably is not. All right. And notice, so I got the x-axis here on the bottom, which lays out where you can see all the values are. Okay. I'm going to pause for a second and then flip over to the Chapter 1 review. But that's it for a comparison of box plots. Okay, so now we're in Chapter 1 review. We're just doing 1.6, 1.6 and 1.7. So 60, make a table, a graph, and a mapping. Okay. All right, here's the table. Draw a T. We're going to have 3 lines underneath it because we got 4 ordered pairs. And then simply this, in what you're given here, these are a set of ordered pairs. This is a relation, bunch of ordered pairs. And for 60, so we got -1 and 1 right here, 0 and -2 right there, 3 and 1, and 4 and -1. Okay, and now we're going to make a graph. And here's -1 and 1, 0 and -2, 3 and 1, 4 and -1. So plot the points. X coordinates go on the horizontal axis, Y coordinates go on the vertical axis. Okay, now make a map. The domain and range, you've got a kind of an oval shape, rectangular to edges rounded off. And you put the domain numbers in the left and the range numbers in the right. And draw the arrows between them. So we got -1, 0, 3, and 4. Now, I put the numbers from the table here. And anyway, so you can see the mapping: -1 to 1, 0 to -2, 3 to 1, and 4 to -1. And then finally we're going to write out the domain and range, and the domain is -1, 0, 3, and 4, but the range does not have 4 numbers in it because -1 is used twice. There's 1, -2, and -1. Okay, now 62, you're going to write a relation as a set of ordered pairs. So you start with the curly bracket, and then you put each ordered pair that's in the table, 5, 3, it's in the parenthesis, and the coordinates, the x and y coordinates, are separated by a comma, the x-coordinates on the left and the y-coordinates on the right. And then a comma separates each ordered pair. and the curly bracket finishes it off. Okay, 64, gardening. 7 plants for every 10 seeds. So the seeds are considered to be the explanatory variable or the independent variable, and the plants are the dependent variable or the consequential variable, or however you want to look at it, think of cause and effect or something like that. So we don't get plants unless we put in seeds. So 7 out of 10 is a 0.7, or you could write it as 7/10. That'd be fine. Okay, either one is okay. But that's the rule. Now, you didn't have to write the rule in order to solve this problem, but that's the logic that's between it. So underneath it. So if you plant 50 seeds, out of those 50, 7/10 will become plants. The expected number of plants is 7/10. Okay, the predicted number, because this comes from some kind of linear regression process or whatever. Well, whatever. Okay, so 50 times 7/10 is 35. 100 times 7/10 is 70. 150 times 7/10 is 105, and 200 times 7/10 is 140. All right, now let's look at the next page, and we'll have to come over a bit. All right, 66. Is it a function? Well, you got 5 points in 66. Could be a parabola. Y equals x squared. Fits that pattern, but we don't know if it goes off and does something else. So we don't know what the model is. But for these 5 points, if you put a vertical line through each one of those 5 points, you would not hit any of the other points. So it passes the vertical line test. So it is a function. Another way you could look at it was look at your ordered pairs. You got -2, 4, -1, 1, 0, 0, 1, 1, and 1, 4. Okay, so if you look at the domain is -2, -1, 0, 1, and 2. And you do not have any domain member that has more than one range. So for each domain, there's one and only one range. Okay, so anyway, 66 is a function. 68, we're going to find each value based on function rules. Okay, so 68, f of -3, f of x equals 2x plus 4. So f of -3 is going to equal 2 times -3 plus 4. We simply plug the -3 into the function. -6 plus 4, -2, 70. F of 0, f of x equals 2x plus 4. 2 times 0 plus 4, so f of 0 equals 4, which is the y-intercept. The definition of the y-intercept is what y equals, or f of x equals, when x is 0. 72, f of m plus 2. So the rule is f of x equals 2x plus 4. So in place of x, we'll put in m plus 2. F of m plus 2 equals 2 times m plus 2 plus 4. So that would be 2m plus 4, the distributive property, plus 4, 2m plus 8. 74, grades. Teacher claims that the relationship between number of hours studies for a test and a test score. So number of hours studied is x. The test score is g of x. Okay, so this is a linear equation in the y equals mx plus b form, where 45 is b and 9 is m. So the y-intercept is 45, the slope is 9. If the student studies 0 hours, so if x is 0, the number of hours studied is 0, the predicted score is 45. Okay, so you can't, according to this model, you cannot get lower than 0, or lower than 45 on this test. For each hour the student studies, the predicted score increases by 9 points. So if the student studies 1 hour, his grade goes, his or her expected grade would go from 45 to 54. So here's the graph, the way I set it up. Notice the difference in scale. On the x-axis, each pair of squares here is worth 1. On the y-axis, we make a little jump here from 0 to 45, symbolized by this squiggle. And then once we're at 45, which is right here, which is the y-intercept, each pair of squares is worth 9 points. So this is hours studied, and this is score on the test. So you can see it's a straight line. It doesn't look like the slope is 9 because of the different scale that I use. Now, the domain, this doesn't ask you for the domain and range, but we can see the domain and range just by looking at the graph. So the domain goes from 0. You can study 0 hours, but you really can't, in terms of the domain, you can't really study more than 7. I mean, obviously, you can study more than 7 hours from a test, but according to this model, the domain is going to end around 7 because it's hard to conceive of how you could get more than 108 on a test. We're assuming that this test goes to 100%, and I'm allowing for extra credit, so you could get 108. People get extra credit on tests and get over 100. Okay, but they're not going to get a whole lot beyond that I could see. So we'd say the domain was between 0 and 7 or 8 at the most. The range, remember we said you can't get lower than, you can't study less than 0 hours, right? You can't study -1 hours or -2 hours or something like that. That's not allowed for in our model. So the range is going to go from 45 to 108. So the domain is from 0 to 7, and the range is from 45 to 108. Maybe allowing for the range to go a little bit higher and for the domain to go somewhat higher than 7, and maybe the range go a little bit higher than 108. But according to the graph, the way I see it, the domain 0 to 7, range 45 to 108. That would be a good extra credit question to ask. All right, and that's that.